10 years ago, every developer managed deployments themselves, but over time, systems became too complex, so companies had to delegate that responsibility to dedicated roles. That's how DevOps was born, which stands for Development and Operations. Nowadays, it has become a soup of 100 different tools you need to know just to deploy your app, so I'm here to help you untangle it. Linux is the foundation of DevOps. It's the operating system core on which almost every cloud server runs. Usually it has no GUI, so you need to know terminal commands to interact with it. Its sole purpose is to run apps like your backend server, for example. AWS or Amazon Web Services is a cloud platform built to replace physical servers. Managing your own on-premise servers is a nightmare. You need a dedicated room for them, you have to keep them running in case of a tornado, and you must cool them so they don't set your house on fire. That sucks. Instead, you just rent Amazon's infrastructure and run your apps there. You no longer worry about the hardware, but you do have to worry about the bill, which is often so high that even Elon Musk would not be able to pay it. There are also alternatives like Google Cloud Platform or Microsoft Azure, but it's basically the same concept. Docker is a tool that packs your app into a small image and lets everyone run it inside an isolated container. Let's say you have a project and your friend wants to run it locally. If they don't have Java installed, they'll just get an error. With Docker, you can specify the exact language versions, environment variables and dependencies needed. Anyone with Docker installed can then spin up your app instantly without configuring anything else. You also ship your app to production this way, ensuring the server runs the exact same code you do. Now let's say your app grows to 2 backend servers, a front-end instance and 2 databases. Oh crap, now you have too many Docker containers and managing them becomes a headache. One container might crash with an exception, another needs a replica to handle traffic, and doing this manually is just too hard. And that's exactly where Kubernetes comes in. It allows you to define your entire configuration in a YAML file. You can simply state, if this container dies, replace it with a fresh one automatically. Now everything works smoothly. But what happens when you get tired of setting up the exact same servers and databases on AWS over and over again for different environments? It would be awesome to have a single command you can run to provision everything automatically. Oh, how fortunate that we live in a world where Terraform exists. It lets you write configuration files stating exactly what you need. One server, 2 databases and some networking rules. You run one command and boom, your infrastructure is live. So write once, use multiple times. But we still have one more problem. Every time you push a commit, you need to verify if the code compiles, run tests to make sure nothing broke, build the Docker image and deploy it to the server, and doing this manually for every change is exhausting. This is the perfect use case for Jenkins. Instead of manual labor, you configure a slave. I mean, you configure a dedicated server that will handle everything for you. You just commit the code and let the server do the job. There are also modern alternatives like GitHub Actions and GitLab CI, but they follow the exact same logic. Finally, it would be great to have a dashboard to monitor your application to see how many users are accessing it, how fast it responds, and whether it's even alive. For this, DevOps engineers usually pair Prometheus and Grafana. Prometheus acts as the collector. It scrapes the metrics exposed by your app and processes them. Then, Grafana reads those metrics from Prometheus and displays them on beautiful, customizable dashboards so you can spot errors in real time.